Hello everyone, welcome back to our IB MYP Mathematics journey. In day 1, we learned that mathematics is not just about answers. It is about thinking, investigating and asking questions. In day 2, we explained about the patterns and sequence. We learned that how mathematicians look for relationships and use patterns to make predictions. Today we are going to learn one of the important skills in IB mathematics. In fact, this skill is so important and this appears in entire mathematics MYP journey. Today's topic is mathematical communication. Now you might be wondering, what does communication have to do with mathematics? Isn't mathematics just numbers? Isn't mathematics just solving some problems? Let's find out. Imagine I ask two students the same question. The question is, what is 25% of 80? That is 25% of 80. Student 1 write as, the answer is 20. Student B or student 2 write as, 25% of 80 means 25 by 100 of 80. So it means 1 by 4 of 80 is equal to 20. Both students write the same answer, right? But which answer helps us to think how to get the answer? Student 2, right? Why? Because student B explained the process. They communicate their reasoning. And this is exactly what IB mathematics values. Let's talk about something important. In many classrooms, students are rewarded mainly for getting the correct answer. In IB mathematics, the answer is important, but the reasoning is also equally important here. The examiner wants to know, how did you get the answer? How did you think? Why did you choose that method? Can you justify your answer? Can any another person understand your explanation? Let's try an activity. Look at the sequence. 2, 4, 6, 8, 10. What comes next? You know it. It is 12. It is correct. Now imagine that I am asking, how did you get this answer? How do you know it? Some students may say that I just know, but mathematicians need something more stronger answer. The better explanation would be, each number is increases by 2 here, right? So here 2 plus 2 is 4, 4 plus 2 is 6, 6 plus 2 is 8, 8 plus 2 is 10. So the answer will be 10 plus 2, that is 12. Now the explanation becomes stronger, right? Let's investigate another pattern. 1, 4, 9, 16, 25. The answer is very nice, 36. So how did you get that answer? Just explain the process. These numbers are square of the numbers, right? 1 is 1 square, 4 is 2 square, 9 is 3 square, 16 is 4 square, 25 is 5 square. Then the next number 36 means 6 square. The explanation is clear, right? It uses mathematical language. It shows the understanding. This is called the mathematical communication. Now let's discuss about mathematical vocabulary. Every subject has its own language. Science has scientific language, music has musical language, mathematics has mathematical language. Instead of saying the line goes up, a mathematician might say that the graph has a positive gradient. The graph has a positive gradient. Did you get it? Instead of saying the numbers get bigger, a mathematician might say the sequence increases. How? Instead of saying the shape looks the same, a mathematician might say that the figures are congruent. The figures are congruent. Using correct mathematical vocabulary helps us communicate accurately. Let's do a real IB style investigation. Okay? Imagine a school is selling some tickets for a concert. Student tickets cost rupees 100 each. Adult tickets cost 200 each. In one day, school sells 30 student tickets and 20 adult tickets. How much money did the school collect? Let's calculate. So here 30 students, right? So 30 into 100. Here 20 adult. So 20 into 200. So the answer will be 3000 plus 4000. So the answer is 7000 whole. Now the task is explain how did you get this answer. That is, the school sells 30 student tickets at 100 each and 20 adult tickets at 200 each. So they generated 3000 rupees from student tickets, and from adult tickets they generate 4000 rupees. So by adding both amounts, we will get 4000 plus 3000 is equal to 7000 total. Now the explanation tells a story, right? The mathematics is clear here. Now let's discuss about diagrams. Communication is not only by words. Mathematics communicates using tables, graphs, charts, diagrams, symbols, models, etc. Suppose I ask, how does temperature change throughout the day? You could write a paragraph or you could draw a graph. Sometimes a graph communicates information much more effectively. That's why IB encourages students to use multiple type of communication. Let's look another example. A rectangle has a length of 8 cm and 5 cm width. Find the area. Most students will write the correct answer like 40 cm square. It is correct. But let's communicate our reasoning. Like area of a rectangle, area of a rectangle is equal to length into breadth. So here length is equal to 8 cm and breadth is equal to 5 cm is equal to 40 cm square. Now anyone reading your work will understand your thinking, how you get the answer. This is very important here. A strong mathematician is someone who explains clearly, think carefully, and communicate effectively. Sometimes a student may take more time but explain beautifully, demonstrate the deeper understanding. Today also we learn about mathematics is not just solving the problems, it is also about communicating the ideas. Mathematicians explain, they justify, they use precise language. The better we communicate our thinking, the stronger mathematicians we become. So today's homework is find the next number. 7, 14, 21, 28, 35 dash. Write a complete explanation. Next question is 1, 8, 27, 64 dash. Next question is find the area of a rectangle with length 12 centimeter and width 4 centimeter. Find the area and explain each step. So today's video is ending here. You are already beginning to think and communicate like IB mathematicians. In day 4, we will explain one of the most important skills in IB mathematics, that is problem solving strategies. You will learn how mathematicians tackle unfamiliar problems, think creatively, and find so many methods to solve that problem. So, have a wonderful day. Take care. Bye bye.